the equation of velocity. Acceleration was left. Let us just quickly complete acceleration because already a lot of time has been gone and one more student also left. Let's see how much we're able to complete today. Because we are towards the end only, oscillations will be completed, then we are left with only thermodynamics and kinetic theory, which are very short lessons. Okay, acceleration will be now, if you differentiate the equation of velocity, it will be minus omega square a cos omega t plus phi naught. Now, this is the equation as discussed in the last class, that we have equations with respect to function of position and function of time. So this is with respect to function of time. Again, with respect to function of position, we'll have minus omega square x. Similarly, at mean position, see, exactly at the mean position, we'll assume it to be x. And as it will go towards the extreme position, we have the equation of the amplitude. This is the extreme position.
Ma'am, did we finish velocity in the last class? Did we finish velocity in the last class?
Yes. Velocity was completed in the last class.
Okay.
So see, when we are talking about the mean position, so if we put x equal to 0, we'll get acceleration also 0 because acceleration is minus omega square x. So this will directly be 0. So we have now the minimum value of acceleration. For extreme position, x will be equal to a. A we take as a separation till the maximum amplitude from the mean position. So equation will be minus omega square. This will be the maximum value which is possible. All right, we'll see questions also based on this. This question we will see. But first write down acceleration portion.
I'm in the last class, I have only written till displacement. Like,
Yes.
I'm in the last class, we did till displacement only.
No. Velocity also we completed. Siddhika was there in the class.
Ma'am, on Saturday?
No. Regular class we had.
Okay.
Last class you didn't join, Harsha. This
Okay.
part, I'll just show you so you can take the screenshots. Displacement was over. We had completed the leftover portion of displacement and then velocity was also done. Yes, I remember Siddhika was there. She was unwell. She's unwell. That's why she couldn't join today as well. That's why I had to leave the class early. I had to end the class. So you can take the screenshots so that you can copy it down later.
Ma'am, I have a doubt in a question in oscillations. Can I send that?
Yes, send it on WhatsApp. Harsha, this question also was discussed in the last class. The same question I
Okay.
had discussed. See, for simple, this is question from NCRT. I'll show you. I'll show you. Just first, let's complete this. I'll show you this. Some of the parts, D part and A part, B part, many parts are discussed from this after displacement only. That's just a trick to remember. It's very easy. I'll tell you that. Just let us complete some portion, then I'll discuss. Okay, this question says a particle executes SHM with time period of 4 seconds and amplitude 10 centimeters. You have to find the displacement, velocity, and acceleration after 1 by 3, 1 by third seconds. That is 1 by 3 is the time duration. That is starting from the mean position. That is, you will take x equal to 0. Both the cases are there in velocity, acceleration, and displacement. And extreme position. For extreme position, one thing remember that we take it as the amplitude A. Let me discuss this. See, time is 4 seconds, amplitude is 10 centimeters, which is written as 0.1 meters. Omega, this is 2 pi by t. So this will be 2 pi by 4, that is pi by 2 radian per second. We have the time as 1 by 3. Also one thing, we have the equation as A sine omega t. So what should our equation be now? 0.1 A, then sine, then omega, and t is this. So equation will be 0.1 sine pi by 6. Pi by 6 you can substitute also, you will get half. So x will be equal to 0.1 by 2 meters. So this is all about displacement. Now, whenever we have to find out velocity, I've told you Instead of directly going by the formula, just differentiate it first. The way we have been using it in motion in 1D, differentiate it first. So d over dt, it's 0 point sine pi by 2 t. So velocity will be, see 0 0.1 is already a constant, pi by 2, and sine becomes cos, again pi by 2 t. The way we write now, 0 0.1 omega cos omega t. So here we'll be having this. Now if we substitute the value, this will be 0 0.1 pi by 2 cos pi by 2 into 1 by 3. So velocity will be 0 0.1 pi by 2 cos pi by 6. So this will be root 3. So this will be 0 0.1 pi root 3 by 2 meter per second. So this will be the velocity. When we are calculating the acceleration, for acceleration, we'll further differentiate this dv over dt. So dv d over dt. Now the entire equation 0 0.1. Again, we have sign back in our answer. 0 0.1 pi by 2 cos pi by 3 t. So acceleration will be 0 0.1 pi by 2. This will be minus omega sine omega t, like this. So acceleration will be minus 0 0.1, pi will be taken. That becomes pi square. This pi multiplied to this becomes pi square by 4. This 2 and this 2. And we are left with sine pi by 2. This term will be left now. T will be 1 by 3. So acceleration will be minus 0 0.1 pi square by 4 sine pi by 6. So acceleration is minus 0 0.1 pi square by 4 into half, you can write meter per second square. Simple, just keep on differentiating. The way we have derived all the equations, solution to it is also the same. Start writing it from here.
Mom, while taking x equals a sine wt, we don't consider the phase.
Yes.
While taking x equals a sine wt, we don't consider the phase.
A phase constant that is coming.
Yes, ma'am.
There is no mention of the phase constant. So even if we take it, that will be cancelled. We have to assume it to be 0. Whenever you are starting from mean position, sine will come. When we'll talk about the same thing, if the same question, second part, this is the first part that I have solved. For the second part, extreme position, same thing, this will be a cos omega t. So this is one thing I told in the last class also, that for mean position, whether it's to start the displacement equation by a sine omega t. If phase difference is given, if there's a difference between two waves that is given, because here only one wave, we were talking about one single particle. So there won't be any phase difference. So this would be the displacement that would be covered by it. Also, start with sine. If we are talking about extreme position, then you have to start with cos. So you can repeat the same question if you're starting with cos. Then you will see, because of cos, the values will be different. Understood?
Okay, ma'am. I mean, the final answer, it should be divided by 4, right? For velocity.
Where?
From cos pi by 6. It will be root 3 by 2, right?
Okay, one more 2 you are saying. Yes, yes, please correct it. Right, right. It would be 4. This 2 is already here and one more 2. So it would be into 2.
Ma'am, for extreme, we should consider x as a.
In extreme,
Yes, ma'am.
yes, that will be x. This equation, x will be equal to a. These are fixed for both velocity and acceleration. But it's just that for starting, you have to remember because you have two equations. Both are SHM means cosine curve and sine curve both. So you have to decide it's sine curve or cosine. So you cannot randomly take. So for that, we have mean position, you have sine, and for extreme position, you have cos. Done?
Yes, ma'am.
This you have completed, no? Okay, let me discuss. This is also a good question. A particle executing SHM along a straight line has a velocity 4 meter per second when at a distance of 3 meters from mean position and 3 meter per second when at a distance of 4 meters from it. Find the time it takes to travel 2.5 meters from the extreme position. See, V1 velocity is given as 4 meter per second. This is a very, very common question. It's very easy. You will be able to solve it once we have discussed, but it repeatedly comes in the exam. V1 is 4 meter per second. V2 is equal to 3 meter per second. These are the two velocities that are mentioned. X1, that is displacement from the mean position. Distance, yeah. This is 3 meters. X2, distance from it is 4 meters. So, equation with respect to position. Now see, everything is given with respect to position this time. In the previous question, we had the discussion that was time was mentioned 1/3 second. So in velocity also we had seen two equations. One was with respect to position, one was with respect to time. Now this is a question of position. So we will put V is equal to omega under root a square minus x square. This is the equation. So two equations we'll have. 4 is equal to omega under root a square minus 9, 3 square. And this will be 3 is equal to omega under root a square minus 4 square, that is 16. So you have this as the first equation, you have this as the second equation. So if we take the ratio 4 by 3 because both are variables. A also we do not know. Omega also we do not know. So this will be omega under root a square minus 9 divided by omega under root a square minus 16. So omega will be cancelled. And what are we left with? Okay, let's square this. So this becomes 16 by 9 is equal to a square minus 9 divided by a square minus 16. Right. So let's cross multiply then. If we cross multiply, this becomes 16a square minus 256 is equal to 9a square minus 81. So 6a square minus 9a square is equal to 256 minus 81. This is 7a square is equal to 175. This is equal to 175. So a square is equal to 25. A is equal to 5 meters. You have the value of amplitude. So put it in any equation. 4 was equal to omega under root a square. So that becomes 25 minus 9. 4 is equal to omega 25 minus 9, 16. Under root 16 is also 4. 4 cancelled. Omega is equal to 1 radian per second. Now you have the value of omega. You have the value of amplitude. Any portion comes, you will be able to solve it. Now, in this question, it had mentioned something. Find the time it takes to travel 2.5 meters from the extreme position. Now we have the value of omega and we have the value of the amplitude. So it's not a big problem. From the extreme position, it is saying, so we'll use cos. As I've told you, we'll be using the cos equation. So this will be if we have cos pi, okay, this we have to calculate, no? So we'll start with x is equal to a cos omega t, no? X, this is given in the question, 2.5 meters. So 2.5, amplitude is 5, cos omega is 1, t we do not know. So this will be 25. This becomes half. 0.5, yes, so that will be half. So half will be equal to
And the
cos
distance
t.
is given as measured from the extreme position, so it's we
So
can.
even if you, this is 5, no? Total is 5. This is 2.5, this is 2.5. So when we are taking it from here, this is also giving 2.5.
Okay, ma'am, but in case it wasn't like that, then we'll have to
Then you have
manage.
to subtract it from the amplitude.
Okay.
Okay, because we always take it from the mean position. This is the
Okay.
mean position. So half cos t, that is cos pi by 3 will be pi by 3. Yeah, pi by 3. It will give you, so time period will be equal to pi by 3 seconds. Note it down. One graph part we will see.
So if time is given, we'll use the differentiation, and if position is given, we'll use this formula.
Yes, Harsha?
If time is given, then we'll differentiate for velocity. And then if position is given, then we'll use this formula.
Yes, yes. If because here position was already given, so we have two equations. So otherwise you will be using the other equation, x is equal to a cos omega t directly.
Okay. Amplitude cannot be negative.
Yes, Harsha?
Can amplitude be negative?
Amplitude, see, amplitude can be negative in the sense, see, it's distance. So the way distance cannot be negative, amplitude cannot be negative. But if you are having amplitude negative anywhere, just in case if you're having it, so that is showing you that the direction is becoming opposite to the direction of mean position. For those purpose only we have the amplitudes as negative. Otherwise, your amplitude is positive. Negative sign is not for the distance, because distance will always be positive anyways you take, because this is not displacement. We are taking the entire distance. But whenever it is negative, that is telling you that the direction that we have calculated, it's from the extreme position. And similar is the logic for force also, away from the mean position towards the mean position, because this is our reference point, the mean position.
So we don't consider -5 here.
Yes.
So we don't consider -5 here.
No, we don't consider -5, because
Okay.
we are calculating the distance. I'm telling you, if you have questions where you are getting the values. Okay. Plus minus amplitude, basically, whenever you have plus minus amplitude, that is from the mean position to the extreme, minus is from the extreme back to the mean position. It's telling you this only. Understood? And if you are solving questions like, suppose we take this. This is a square. So when you'll take under root 25, you have plus 5, you have minus 5. So we neglect that minus 5 because you already have plus 5 in your system. Suppose your answer by all the calculations is coming minus only. That tells you that the calculation has been done from the extreme position to the mean position back.
Okay.
Okay?
Yeah.
Done?
No, ma'am, right.
Okay, completed.
Done.
Okay, these are certain standard graphs that can come in the exam. So these are fixed for all the questions. Very easy graphs to be plotted. But we'll discuss all of these: displacement versus time, velocity versus time, and acceleration versus time. These graphs come. Because for position remains variable depending upon it. But for time, we choose some values because these are angles. So sine and cosine curves are like this only. But how do we start it? So see, x is equal to all these three equations first you should know. A is equal to a cos omega t. Differentiating it gives velocity, that is minus omega a sine omega t. Differentiating it further gives minus omega square a cos omega t. Now, first equation, that is x is equal to a cos omega t. So for cos, we always have this graph. When you will come in class 12th, you have a lesson alternating current. There also this entire concept comes. So it's better if you remember it in class 11th only. That will be helpful there in class 12th. Cos curves are always starting from this. Sine curves are starting from the baseline. This is how you can remember whether it's a sine curve or a cos curve, by just looking at the curve also. So A is equal to cos omega t. So we have just divided it into four parts: t by 4, t by 2, 3t by 2, and complete t. Why? Because one time period we are taking. So best way is to divide it into four parts. You can divide it into two parts also, but four parts will give you precise information. Even you can divide it into six parts further, but four is sufficient because in the NCRT also it's mentioned into four parts only. So t by 4, then this is how one cos curve is completed. Then from here, why? Because this is reaching here back. Now from here, next curve will start. Again, it will follow this path. Then again, next curve will start from here. Like this, you have the cos curve. Sine curves always starts from the baseline. But since our velocity is negative, minus a sine omega t, see, this is what I was referring to. Here, amplitude is calculated from 0. But why we are taking it negative? Because we are calculating it, we are taking it the direction to be opposite. Otherwise, the amplitude is not, it's just the distance that has been traveled. Displacement, you can say. And you also know why displacements are also negative. So similarly, so from 0 we are starting, but since this is negative, velocity is negative, our sine curve is negative. So instead of drawing it like this, we are drawing it like this. So one curve till the baseline, then again from the baseline it will start, and this entire separation is one wavelength, and this is the amplitude A which we are writing. A's value is this. So at the extreme, maximum value is minus omega, which is possible. Here also, this is plus omega a, which is possible. Then further differentiating this gives acceleration. So acceleration is minus omega square is the maximum value which is possible. Now this is the cos curve, but again this is negative. So negative, then again it will complete. You have to keep on drawing the waves till it reverses, till it repeats itself. Because from here the next wave will start. So at least this much you should draw. Here you don't have to think much. You just have to draw as it is. This comes in the exam. That's why I've written it separately. It's like a topic rather than a question. As it is, this question comes without any modifications. So, but you should, basic idea is that you should remember the curves. Once you know how the curves start, if you remember cos curves are like this, so negative of cos curves will be this one. Sine curves are like this from here, like this. So negative of it is like this. You have remember this concept for class 12th also. For alternating current, it would be helpful. Write it down.
I can take x as a sine wt also.
Yes.
We can take x as a sine wt also.
X as you can take it as sine also. But then you have to start it from, you have to just mention which you are taking, from the extreme or from the mean position.
And
Then
that
it
would
would,
also
then
be
if
right.
it is a sine omega t, if you're taking, then like this you will draw from here. That's what I was saying. Just remember how cos and sine are drawn. Then for negative, you can reverse. For positive, like this you will draw. Then again from here, next curve will start like this. See, now when we're talking about the energies in SHM, so when we are talking about the total energies in SHM, you have the kinetic energy and the potential energy, both the energies which we have discussed. So kinetic energy's formula is half mv square. Velocity is equation we know, minus omega a sine omega t plus phi naught. So when we are talking about kinetic energy, this will be half m. Now v square, so square this term. This will be omega square a square sine square omega t plus phi naught. And as I've told you that this is already taken for the sign of the direction of the wave. The kinetic energy is a scalar quantity. We'll not put the negative sign. So this is as a function of time. V is equal to omega under root a square minus x square. So as a function of position also, we should have the equation. So kinetic energy will be half m omega square a square minus x square. This was under root. So after squaring, root has gone. Again, for mean position, you have x equal to 0. For extreme position, you have x equal to a. So as soon as you make it equal to a, this cancels and becomes 0. And this is equal to a square. So a square minus a square, this is the maximum value which is possible. Then talking about potential energy, same thing in potential energy also. Half kx square, we have discussed this in work energy in power. That's why I've mentioned this, that this derivation we have already discussed. And that time also I told you that this will be repeated in SHM. So x is equal to a cos omega t plus phi naught. When we're talking about this, this becomes half k x square. So this is a square cos square omega t plus phi naught. Again, this is a function of position or time, sorry. This is function of time. So u is equal to half kx square is a function of position. So when we're talking about this, then again, we have both the conditions. We have the mean position. For mean position, x will be equal to 0. So potential energy will be 0. That is, at the mean position, you have the minimum potential energy because there is no displacement. There is no change in configuration also. Apart from mathematical derivation, you can remember it like this also. But secondly, when we are talking about extreme position, x will be equal to a. So u will be equal to half k a square. This is taken as the maximum value. Also, you know, omega square is equal to k by m. This also we have discussed in the initial class only. So when we are doing second order differential equation, so the u is equal to half m omega square a square also. This also you can use it. So write down all these equations, then I'll discuss it.
Done, ma'am. Done, ma'am. Ma'am, can you scroll down? Done, ma'am. Done, ma'am. Ma'am, I have another class, so can I leave?
You have class right now?
Yeah, ma'am, an extra class.
Which subject?
For doubt. Chemistry, ma'am.
Okay. Okay, okay then. So same meeting ID, Harsha.
No, ma'am, different one.
Different meeting idea. Okay, then I'll discuss that question in the next class, or if you can watch the video, let me know.